already answered. Thank you.
Okay. See you, Bobby. All right, live stream should be happening. All right, so the first thing to do here, Abby, is to factor the denominator. And most likely, so you know it's got to be 2x and x, right?
Hmm.
And now since this is x minus 3, I'm just going to guess that this is x minus 3, which would mean this would be x plus 7, because that's
Yeah.
just usually how it works out. And
Yeah.
sure enough, it works that way. Okay, so now that I've done that, I'm rewriting it like that. Okay, and now to add to combine like terms, I have to have this. I have to have the same denominator, so I have to put an 2x plus 7 in the top and the bottom of this one. That makes sense?
Yeah.
And that way it would allow me, I would have the same denominators. And of course, if I multiply the bottom by that, I have to multiply the top by it too.
Hmm.
Got it? So
Yeah.
then that would allow me just to rewrite this entire thing like this. And now the numerator, let's go ahead and simplify that up there. That's negative 10x minus 35. So now let's add like terms. 12x minus 10x is 2x. 42 minus 35 is what? Positive 7. Well, look at this. What's going to happen? What's going to happen to this and this now?
Oh, they cancel?
They cancel, and I get 1. Don't forget to leave the 1 on the top and the x minus 3 on the bottom. But when you do this, you have to put a restriction. You have to say that x cannot equal what you just canceled out. Or in other words, you can't, that can't be equal to 0. So set the 2x plus 7 equal to 0 and solve. So x 2x can't be equal to negative 7, which means x can't be equal to negative 7 halves. I don't know if your teacher makes you do that or not, but
Yeah.
technically
Well,
you
on
should do
some
that.
of them it says like put the domain, but some of them it just says to like simplify.
Yeah, technically you should do that, what I just did.
Okay.
Because when you cancel, anytime you cancel something out, you have to put the provision. These two things are the exact same function, except for at the point x equals negative 7 halves, because you can't put x equals negative 7 halves into this equation. You get 0 over 0,
Yeah.
but you can put it into this one. Okay, so
Okay.
you should always do that just to be safe. All right, got another
Okay.
one?
Yeah. It's 4 over x minus 1 minus 8 over x plus 1. Um, and that like those two divided by 1 minus 2 over x minus 1.
Sorry, all divided by, say it one more time.
1 minus 2 over x minus 1.
Okay, so for a problem like this, I'm going to teach a trick. Some teachers don't show this. I don't know why, but it's such a nice little trick to know. Find your least common denominator, which is that and that, right?
Mhm.
X minus 1 and x plus 1, because it's here too, right? And
Yeah.
multiply the top and bottom by that. So I'm taking this whole compound fraction and I'm multiplying the top by it and the bottom by it. Make sense?
Yeah.
Totally legal to do. And when I do that, what happens when I multiply it here? What happens? Here, let me color code this. What happens when I multiply this thing here? What cancels out?
Uh, the denominator?
The x minus 1 cancels out, right?
Yeah.
Can you see that? And then what would you be left with? 4 times what?
8?
X plus 1.
Oh, okay.
Do you see what I'm doing? Let me do it again. When I take this and multiply it here, the x plus 1 and the x minus 1, the x minus 1's cancel out, and I just have 4 times x plus 1.
Wait, so you multiply like the x minus 1 and the x plus 1 times the 4 and the 8?
Let me show it to you another way. You're not seeing it. I'm basically going to take this whole thing. Was that you or me that just messed up? I think you just moved my.
Oh, sorry. Wait, my
That's
bad.
okay. That's okay. So this right here, I'm going to multiply it by everything. I'm going to
Mhm.
multiply it here. I'm going to multiply it here. I'm going to multiply it here. This is called clearing the fraction. And I'm going to multiply it
Oh.
here. I'm going to
Oh, wait, I
multiply it
get it.
by
So, like, then the
everything.
x minus 1 cancels out on the 4, and the x plus 1 cancels on the 8.
Exactly. So when
Okay.
you do that, watch how cool this is. That just cleans up your equation really nice. And you have this cancels with this, and all you have is a 4 times x plus 1. This cancels with this, and all you have is a negative 8 times x minus 1. This doesn't cancel with anything because there's nothing in the denominator, so just write it
Yeah.
out. And this cancels with this, and it's negative 2 times x plus 1. And then I can now see how it's a much simpler equation
Yeah.
or
And then
expression.
when you, like, get to that, like, can you cancel out, like, the x plus 1?
No, no, no,
Okay.
no. No,
Okay.
because you're the only reason you would be allowed to cancel this and this is if it was a factor of the entire top and the factor of the
Okay.
entire
Okay.
bottom,
Yeah.
which it isn't, right? So remember when you're doing like, I don't know, 4 plus x all over 5x, or let me just even do 4x. Can I cancel those x's out or those
No.
fours out? No, I can't do that. The only reason that I would be able to cancel them is if I could like rewrite it, right? Like
Yeah.
if this was 4x and that was x squared, then I could rewrite this as x times 4 plus x all over 4x. And now these two could cancel out because I could think of like pulling them out to the front and putting these things here. That's like the same thing. And this just equals 1. That's the only reason you're allowed to cancel things is because a number over itself is equal to 1 and you can cancel. That's what you're doing. You're canceling to 1. But these can't be up here. These can't be canceled to 1 because they're not factors in the entire top and the entire bottom. So I have to distribute this negative 8 in. I have to distribute the negative 2 in. I should multiply this out. X squared minus 1. Remember how the middle term is going to cancel out. And now I can add like terms. Oh, and I multiply this in 4x plus 4. So this is 4x minus 8x is negative 4x. 4 plus 8 is 12, right? And on the top, I have x squared minus 2x minus 3. Now, I might want to cancel. I might want to see if this factors more, which it might. I bet it will, actually. Now I can factor out a negative 4 of the top, and I would have an x minus 3. And let's see if I get an x minus 3 at the bottom. That would mean it would be x plus 1. And does it work?
Yeah.
It does. And now what can I cancel out?
The x minus 3.
Yeah, see, now I can cancel them out because they're factors of the top and the bottom. That makes sense?
Oh, yeah.
That's why you can cancel them out because what's x minus 3 over x minus 3?
1.
It's just 1. Does it matter what x is?
No.
It except what can x not be?
Positive 3.
Exactly. So also you have to say x cannot equal positive 3. So this whole thing right here, that whole red thing at the beginning, is the exact same as negative 4 over x plus 1 as long as x doesn't equal 3.
Okay,
Oh,
yeah.
and what else can x not equal? Sorry. What else? What other restriction do I have in the very beginning? What am I not allowed to plug in for x?
Uh, negative 1 or
It
1?
can't equal, yeah, it can't equal 1 or negative 1. Now, do I have to write both of those here? What's already what's already obvious that you can't plug in? You can't plug in negative 1, right? Can you see that?
Yeah. Oh,
So I
yeah.
don't have to write that again, but I have to write positive 1 again.
Well, if you wrote like negative 1, would it be wrong or?
It wouldn't be wrong.
Okay.
But you don't have to write it because that's already part of
Yeah.
this problem, right?
Hmm.
Like here at the beginning, you didn't write anything here, but what can you obviously tell that you can't plug in? You can't
Um,
plug in 1 or -1.
yeah.
And you also can't plug in 3 because if you plugged in 3, what would happen to this? 3 minus 1 is what?
Oh, 2.
2. 2 over 2 is 1. 1 minus 1 is 0. And so you'd have a 0 in the denominator.
Okay. Wait, so 2 is 2 another or wait,
3.
3? Oh, but
3.
that
But we already saw that when we
yeah.
simplified it, right? When
Yeah.
we simplified it, it kind of cleaned that up for us, and it showed us that. Okay,
Okay.
you got another one for me?
Um,
Let me make sure I'm still streaming this
yeah.
yet. Okay, I am.
Um, x cubed minus 27 um over x squared minus 4 divided by 2x minus 6 over x squared plus x minus 6.
Okay, so for this one, we don't want to multiply and divide and everything. We're just going to flip this and multiply it on the top. You see the difference between that and the other one? This one we had multiple terms on the top and the bottom. This one we just have a fraction over a fraction.
Mm-hmm.
So for this one, all we want to do is rewrite it as x cubed minus 27 all over x squared minus 4 times, flip the bottom one. You understand why?
Yeah, because of like the keep change flip.
Yep. Now we
So
want
you
to
can like do
factor.
that as the first step, or like do you have to
Absolutely.
like you can
Yeah.
do it as okay.
Yeah.
I
Absolutely.
thought you had to like wait till everything was factored.
No, no, we can do that, but now we want to factor,
Okay.
right? So this is 2 times x minus 3.
Mm.
This is x plus 2 and x minus 2. And remember, I'm going to use those things to help me factor the tops. So this is probably going to have an x minus 3 in it, which means it'll probably have an x plus 2 in it. Let's check that that works. Nope, that's not right. They tricked us. It's going to have an x plus 3 and x minus 2. But I was hoping that it would give me that so we can cancel it, but we can't.
Yeah.
Not yet, at least. Okay. Now this one, remember the soap thing?
Yeah.
So it's the same, opposite, always positive, and you take what's being cubed and put them there and there. You square the first one, you square the last one, and you multiply them together. Right?
Yeah.
And hey, how about that? What can we cancel out? See, now because these are all being multiplied on the top, right? And these are all being multiplied on the bottom. So we have just a bunch of factors everywhere. So that's why we can cancel that factor. Whoops, no, that's not a factor. We can cancel that with that, and we can cancel that with that. So rewriting it, it would be, I'll put this first, x plus 3, x squared plus 3x plus 9, and 2 times x plus 2 on the bottom. But then remember, we have to write what we canceled out. X can't equal what?
3 and 2.
2 and 3. And obviously, it also can't equal -2, but we don't have to write that
Yeah.
because you can see that. Can you see by looking at this that you're not allowed to plug in 2 to
Yeah.
here? Can you see?
Or
No, I'm
no.
saying you can't. That's why you have to write it because originally you weren't allowed to plug it in.
Yeah. So
Okay,
that's like
awesome.
the simplified, like that's all like the most simplified form.
Well, you could see if this factors more, but I know it doesn't.
Yeah. Okay.
Making sense?
Yeah.
All right, you got another one for me?
Yeah. X squared minus um or sorry, plus 5x plus 6 over x squared plus x minus 6 times x squared minus 9 over x squared minus x minus 6.
Okay. This is going to be easier. You could already tell what happens. How do they factor? This top one is just x plus 3 and x plus 2, right? This is x plus 3 and x minus 2, right? Good.
Yeah.
This is x plus 3 and x minus 3. Good.
Yeah.
And this is x plus 2x minus 3.
Mhm.
Did I get all those right?
Yeah.
So notice these are all being multiplied, right? So it's just a
Uh-huh.
bunch of things being multiplied. So that means you can cancel anything that's common on the top and the bottom. So that
Wait,
is,
so is it like if it's like being if it's a multiplication and like they're being multiplied, then you can cancel anything?
yes, because remember what we're doing here is this just equals, here, let me rewrite this. This just equals x plus 3 times x plus 2 times x plus 3 times x minus 3, right? They're all being multiplied on the top.
Yeah.
And on the bottom, it's just x plus 3, x minus 2, x plus 2, and x minus 3. They're all on the bottom. So can I just move any things around that I want, like these right here, that
Yeah.
and that? Can I just say, hey, let's group those together? And what's x plus 3 over x plus 3?
1.
Yep, that's why they cancel out.
Okay, yeah.
And then I can move these together. What's x plus 2 over x plus 2?
1.
1. That's what you're doing when you're canceling the 1. And that's 1. So all I have left is x plus 3 on the top and x minus 2 on the bottom. And I have to be clear that x can't equal -3, +3, and -2. And of course, it still can't equal +2, but I don't have to write that.
Mhm.
Good.
Yeah.
Can I show
Um
you? Can I show you somewhere where you can go to get more practice with this?
yeah.
Okay. If you go to my website, 204tutor.com, and you go to the videos tab up here, you can go to this is called uh, solving rational equations, probably
Yeah.
solving rational equations. We haven't done too many of the solving. You're doing mostly simplifying right now, but
Mhm.
it'll be in that same thing. There'll be some more. These are just playlists of people, just like I'm making a video for you. I put videos on playlists for people writing polynomial. I think it's this one. Yeah. See now this is where it's solving. Have you done solving yet, or are you just doing simplifying?
Like with the graphs?
No, like actual solving.
Uh I
There's
mean
some examples of simplifying right there. See the ones that say simplify?
like the ones that we
Simplify.
were doing?
Can you see my screen or no?
Yeah.
Can you see what I'm showing you? I'm flipping through this playlist.
Mhm.
Yeah. Do you see where it says simplify?
Yeah.
Those are the ones that are more examples like what we just did. And then there's
Okay, yeah.
also where I show you how to do rational functions in here once you get to graphing. And but you're
Yeah.
going to have to you're solving them as well,
Mhm.
right? Have you done
So
the
like
solving ones
solving
yet?
for x?
Yeah. Have you done those yet? None of these were all simplify, but
Yeah.
have you done
Well,
where
we've
it says
done
solve?
like obviously like the simplifying and then also like the graphing with like the asymptotes and
Yep.
the
Okay. Yep.
like that stuff.
Yep.
So that's like the only two like topics we've done so far.
And you haven't done solving these equations yet, where instead of just an expression, it has says equals something, and then you have to solve it.
Uh no, I don't think so.
Okay. Well, you will be doing that soon.
Okay.
Maybe not yet.
Yeah. Um, Also, I had another question about like the graphing.
Uh-huh.
Um, so it was just like one question. Like one of the like oh yeah, okay. So one of the like graphing ones, it was like find the y-intercept and
Mm-hmm.
like the simplified equation was 3x minus 1 um in parentheses 4 or sorry, x plus 4 um over 2x parentheses x minus 1.
Okay.
So like for finding the y-intercept where you like plug in 0 for all the
For
x's,
X. Yeah.
would it
That
be like no like none? Because plugging in like the 2
yes.
times 0, it would be 4 over 0 or
Yes.
negative
In
4.
fact, more than that, it would give you an asymptote, right? What do you do first? You find your asymptotes.
Yeah.
So what are my vertical asymptotes? X
Um,
equals 0 and x equals 1, right?
yeah.
So yeah, if you have a vertical asymptote there, then you can't have a y-intercept.
Oh, okay. Oh, okay, yeah.
So here's 1 and here's 0. Those are your asymptotes. And then your x-intercepts are -4 and positive 1/3,
Yeah.
right? And then let's see what else. We the horizontal asymptote, because the degrees are the same, is going to be 3/2, right?
Yeah.
Because it's that times that and that times that. Your leading coefficient would be 3x squared and 2x squared. So three and a half. So it's like here. Got it?
Yeah.
And so your graph is going to go like this. You know, it's got to go like this here, right?
Yeah.
And you know, it's got to go. Remember how they talked about multiplicities of the asymptotes? Have you learned about that?
Yeah. Wait,
The
so it's like
multiplicity
if
is
it's
one. So you know
is it
this has to go the opposite direction. This has to go like here. And you know it can't, it's not, the zeros are also multiplicity one. So it's got to go through. So you know these have to go through the x-axis like that,
uh
right? So you know your graph's got to do something like that, and this has to be up here. It can't be down here because then you'd have another y-intercept
yeah.
or x-intercept. It's got to be up there, and you know they have to go opposite directions, right?
Yeah.
Like these have to go opposite directions with each other because that's multiplicity one. These have to go opposite directions of each other on that asymptote because it's multiplicity one.
Mhm.
So your graph's going to look roughly like that.
Um
Okay,
yeah. Uh Wait, I like there was like one other thing I was gonna ask.
that's fine.
Um Wait, I'm trying to remember where I like um I don't know, like I just like whenever it says like X, like when you like factor out the X like with graphing, it's
Uh
like
huh.
confusing because when you're like plugging in zeros for stuff, I don't know if it's gonna create um like 0 or oh also yeah, like with
Here, look at this problem right here, Abby. Think of that as 2 times x minus 0 times x minus 1. Now, is that
yeah,
easier to see what that is?
yeah, because I also like where it's like um when you're finding like um the vertical yeah, the vertical asymptote, like I
Mm-hmm.
didn't know if you should just not include like the x equals 0 because
Yeah, you
it's
definitely should.
Okay, because like
Zero is
I
still a
didn't know if I
number.
should make like if the 2x should do like the zero product property or if it's like not supposed to.
Yeah, yeah, it's the zero product property.
Okay, because
Just
like
think
I
of
don't know, like the stuff
2x.
that's
Think of it
when the
like
stuff's
this.
like yeah,
Think of it like that.
okay. When the
Or
stuff's
just
like not in parentheses, like that's like the stuff that usually
no,
like
no,
I
that
get
the
confused
two
with.
doesn't have an impact on it on the zero product property.
Yeah.
The two because that's just by itself.
Uh-huh.
But the x does because the x is like x minus zero.
Yeah.
Zero product property, if I have x squared plus x equals zero, I'm just trying to solve this equation and factoring it using the zero product property helps me solve it easier because if this times this equals zero, the only way that that can happen is if this equals zero or this equals zero. That's the zero product property.
Yeah.
So of course you have to take that single x into account. And
Yeah.
that's why I'm saying maybe it helps you to see it a little bit better if you just think of it as x minus zero, because it is. X is
Mhm.
like x minus zero or x plus zero, right?
Yeah. And like the same thing, because there was another question where like the x was in the numerator. So
Yep,
like
same deal. That's just
so
your
for
x-intercept. So, yep.
yeah, for the y-intercept, it would still be zero. It would be like zero over something, which is still zero. So like there would be no y-intercept, right?
No, there could be a y. There could be a
Well,
y-intercept
because like
still.
it was x, the thing, it was yeah, it was like over one.
Yep.
So but
So
when
what
you're
would your
finding the
y-intercept be?
y-intercept, you plug in zero for x.
Yeah, but now still, what's your y-intercept going to be?
Um,
Let's say it was over 4.
well, if you're
Well,
plugging
that
in zero for x, wouldn't it be like even though there's like the one, it's like wouldn't the x like the zero distribute? So the numerator would be zero?
yeah, it's still 0. But I'm saying that still is a point. So this is first of all is a bad example. Let's do like x minus 5. So what would your y-intercept be for this?
Um,
Plug in 0 for x.
so like
It,
then it would be zero over a negative
it's just
20?
0. It's just
Oh,
0.
so
So
if okay, so
what's
if
your
the
y-intercept? 0 comma 0. It's one of your x-intercepts too, but it's your y-intercept. So
okay.
for this equation, 0 0 is one of your points.
Hmm.
5 is your asymptote, your vertical asymptote. Your horizontal asymptote, this actually has a slant asymptote, not a horizontal. Here, let's make it trickier. Let's make it squared so that we have and let's make this 8 up here. So what would my horizontal asymptote be?
Um, wait. Uh, none,
No, I would have a horizontal asymptote because the degrees are the same.
but one of them squared.
So is this one though.
Oh, because of the oh, okay. I forgot about the x. Okay, so then it would be two.
Good. So there's your horizontal asymptote. There's my x. Where's one x-intercept? Where's another x-intercept?
Um,
This point is 5, by the way.
oh, okay. A -8? Or wait, is it zero?
Where's my other x-intercept? One of them is 0. And what's the other one?
Oh, -1.
Yep, -1.
So zero's a y-intercept and an x-intercept?
Yep.
Okay.
That the point I was getting at is it can
Yeah.
be both.
Wait, so when there's okay, let's say like when there's an x in the numerator, the y-intercept will be 0, 0, but when it's in the denominator, there will be none.
Well, there could be, yes, there will be none, but there also could be a hole there, right?
Okay.
Because if you had an X in the top and the bottom, then it's a hole,
Yeah.
which means you don't have an intercept, but it's a
Mm.
hole. So looking at this equation right here, so um, let's see. So what's got to happen here? I'm actually not sure what this does now that I look at it. It's got to approach. Well, it can't go. It must be doing this. It must be going like this, and it must go like this, and then this. Wait, could that be? Yeah, because it has to approach at the same side, right? Because this is squared, it has to approach it the same way.
Mm.
So you know it has to be above it because there's no x-intercepts over here. It has to be going up like this. You know what I'm
So
saying?
when wait, for like the multiplicities, when it's even, does it have the same end behavior or opposite?
When it's even, it has the same. It's going the same
Okay.
direction
So then like
toward
if
that
it was
asymptote.
like cubed, it would have opposite?
Yeah, if it was cubed, it would change. Yeah, it would change quite a bit.
Okay. 'Cause which there's hasn't been like a lot of questions like about that, but like it has been in a few.
Yeah, it's just a good trick to know.
Yeah.
All what you always can do, Abby, is you can just plug in points just to see.
Yeah,
Like
that's
if
what
you're
I
not sure,
usually
just
do.
plug points in. Yeah.
Yeah. Okay, yeah.
Yep. All right, and go check out my website for more videos for that. Okay.
Okay.
All right. Well, hey, good luck with your quiz tomorrow.
Thank you so much.
Good talking.